So we're going to talk about more gathering information from your network so you can make some smarter decisions on, well, lots of things, but we're talking about power consumption today. So with that, I'm going to hand the stage over to Stephen, who is going to talk about measuring power consumption and other cool stuff.
Thank you. So we had this introduction this morning by Bertrand, right, about what kind of aspects we have in terms of what we can optimize in terms of sustainability. So let's have a look at a very tangible aspect, which is power consumption, right? And in that context, also carbon emissions, which is, of course, also an important point. What can we do today, right? A lot of locations that we see, data centers or POPs, then we have a power meter at least, right? So we know what is that whole location consuming at a given time. But ideally, we want to go into more detail, right? And today I want to talk about how we can do this, either with external sensors or also with just the means that the devices provide us already. We've built a little prototype for live monitoring based on open source components, and we are trying to open source these changes for you. Unfortunately, we're not 100% through the process, but I hope this will be done soon, and this will contain some of the aspects and some of the dashboards that you'll see today. Right. Usually I've seen one of these kind of maps, right, that show you the carbon intensity that goes into producing the power that we all consume at home in our locations. And of course, we have these days lots of power sources that are intermittent, right? We have solar power, we have wind turbines. And so this is not a fixed picture, right? This will change seasonally, right? We have patterns. Of course, in summer we have more sunlight. In winter we have a bit more wind. And of course, during the day there's sunlight, during night usually not. So that's why we see the carbon impact of our grid changing over time. And that's also something that we can measure and that we can incorporate into our sustainability thoughts, right? Power production, power consumption. Well, that's a bit of a debated topic. And what I mean by that is, well, we can usually buy our power from certain power sources directly, right? And I can buy, for example, at home my power from a wind power farm that's nearby through a power provider or through solar farms. But of course, I also want to have power when there's no wind outside, when it's at night, right? So what I get from the power grid is not always what I'm actually buying. And therefore, we've seen advertisements being made by some companies saying, okay, we're running 100% renewable. Okay, yes, you're buying 100% renewable, but that's not always what will be delivered, right? So we have to take that into consideration. Of course, one aspect that we can't really take out of the picture is if you have a data center and you put solar power on top of that, of course, it feeds directly into your devices. It's your solar power, right? And there's no question about that. The same with wind turbines. Now, what is actually the question here is, well, how can we get greener, right? How can we, or at least as a start, right, in order to make these kind of improvements, we have to first measure them. And there's certain aspects in terms of legalization, especially here in the EU, right? We have all these kind of Fit for 55 programs, energy efficiency directives, and so on. And of course, we heard it mentioned before, ESG, Scope 2, Scope 3 emissions, that all have to do, or where all the power consumption and the related carbon emissions come into play. Usually, and as I mentioned that, we have these kind of measurements of energy and power per location, right? But if we want to go into more detail, how do we actually achieve that, right? And I have here a picture from one of our labs in Vimercate, and what you see here, first and foremost, is those two blue and red bars on each rack, right? And these are, of course, the PDUs, the power distribution units that feed our devices. And that could be the first thought, right, that you're saying, okay, I want to measure my power more individually, more granularly. Could I tap into those? And, well, the question is maybe, right, or the answer is maybe, because, well, it depends on your PDU, right? Some PDUs do have power sensors, but some only measure the whole power of the whole rack. Some have some more power sensors that actually feed or that actually measure what goes into a group of sockets, right? So you see they're usually like a bit grouped here. If you have very expensive ones, or I guess if you have that thought in mind when you bought them, then you may have bought ones that have actually sensors on each socket, right? And that's usually, I guess, one of the most easy ways, right, if we're not factoring in the cost here, to measure the power, because then independent of what is hooked up to it, you can just measure the power that's going onto the socket, and if you have some way to associating that using tools like Netbox or something like that, then you can have already individual power measurements. But usually we are not at this stage, right, or we're not assuming we're at this stage. Fortunately, there is lots of sensors, as you know, right, in our devices already, and some of these sensors actually measure power already for us. It depends a bit on the kind of device, what these sensors are, right? So if we assume our data center is fed with AC power and the devices are converting them to DC, then usually we have power sensors on the power supplies inside our devices that tell us how much DC power is going from the power supply into the various components of the device, right? So that's something that we can measure. And some devices, especially the ones that have modular power supplies, they do have also AC sensors, so what goes into the device, right? And why that matters is, of course, and I think Bertrand mentioned it in the beginning, it has to do with the 80+ program, for example, that power supplies, they do have conversion losses, of course, right? Because they are converting power, and what is lost in terms of power is wasted as heat. So, but we have to maybe take a quick step back on power versus energy, right? So these sensors that we talked about here, these are power sensors. And what I mean by that, they can tell you my device is currently consuming 600 watts or something like that, right, at that very second. But they will only tell you what they consume at the time that you measure it through the sensor, right? They cannot directly tell you my device consumed 20 kilowatt hours over the last hour, right? Or 20 kilowatt hours over a day or something like that. You can use a power sensor to approximate that, but then you have to take relatively granular measurements, right? Because you can only approximate on these measurements, but you don't actually know in detail what the device consumed every second, because you're usually not measuring every second, right? That's one of the downsides. So there will be some small accuracy losses, and of course we also have to consider that each power sensor, right, has some certain error tolerance in terms of what it's measuring. And last but not least, there's of course also the factor, right, we are consuming power in our devices, but we are producing heat, and so whatever we use for cooling in terms of energy, we have to, at some point at least, also account for when we consider the individual power consumption of our devices. Right, so since we're here at an automation and Crosswork NSO focus conference, I have to put up some Young models. So you may ask yourself, right, how can I get these values from these power sensors? Well, for some of our platforms, I put it up here, right? In an ideal world, you would go and say, okay, I have this open config model, right? And I get the data from there. Well, yes, it works on some devices, but unfortunately, not everywhere, right? So then you find yourself going back to vendor-specific models, where that's not possible, and I've put the relevant ones up here for our devices, for XR and XE, right? We are converging to that very first model on the majority of our new devices, and you see FRETA is the model for NCS 5500, and of course ASR 9K is the model that we've been using on the ASR 9K. Unfortunately, not all devices do telemetry, right? We know that, or we maybe have still older platforms, so we would have to fall back to other mechanisms like SNMP, and or, well, we have to run show commands and then deal with whatever text output we get from this. But of course, we cannot go into that kind of, well, low intervals in terms of scanning the power sensors with these methods as we can with using model-driven telemetry. So I mentioned that little prototype stack that we built, right? Some of you have worked a bit with time series and with charting of these kind of sensor values. They probably know this stack. It's Telegraph, Influx, and Grafana. Some very popular components. Some of you also know that at some point a couple years ago, we actually open sourced some telemetry collection modules for Telegraph, right, for our XR, XE Nexus telemetry and also for GNMI. You can use these, but of course you can also use Crosswork Data Gateway, which gives you, if you already have a Crosswork setup, of course, the advantage that you have the high availability aspects and a safe storing of the credentials and so on, right? I mentioned that we're not only dealing with the power measurements, but also with carbon, right? So what we do is we use a service called Electricity Map. It's an online application. You can have a look at it, and it shows you a bit like on that chart or on that map that I had in the beginning, but the current, basically, carbon footprint and the current power sources that go into feeding the different electrical grids of different locations, different countries, or even regions within a country where available, right? We're aggregating that data. Of course, we can also consume data from the compute infrastructure. There are protocols like Redfish, which let you, in a vendor-agnostic manner, get temperature and also power information from server platforms. And yeah, I mentioned the PDUs as well. We also have a use case in the end, and we have some more use cases in the upcoming talk with my colleague Guillaume, where we show how we can also use NSO in that picture here. Not for collecting data, but for actioning upon. I mentioned just briefly Crosswork Data Gateway, and there's just some informal, informational picture here that I said, okay, how can I actually use Crosswork Data Gateway with, for telemetry consumption of, for my own applications, right? So you can use the infrastructure API of Crosswork to set up collection jobs, for example, for these telemetry models that I showed you before. And then the data gateway is actually picking up the data for us. It's putting the data on the Kafka broker or gRPC server of our choice. And then we just have to do, sorry, then we have to just deal with a bit of decoding and flattening the output data. The data is either in JSON format or protobuffer. So if we want to feed that into time series database, we just need to format it a bit, and then we're good. Let's actually have a look at some concrete cases. So what can we do with the kind of sensor data that we're gathering, right? So first and foremost, of course, we can show what is the current power consumed by some of our devices, and I've grouped them here a bit by platform. That's what you see in the first column, right? In the second column, you also see what's the required power. Now, the required power is a value that tells you in the worst possible conditions, what's the power draw of my device. That means very hot environment, fan needs to run on full speed. And of course, it also depends on if you have a modular device, what kind of line cards you have inserted or installed, what kind of optics are plugged in, and so on, right? And in the third column, we use the CO2 information that we get from that electricity maps or CO2 signal API. And we can multiply that with our power consumption, and then we get an idea of how many grams of CO2 equivalent are emitted just because our device is operating on the power grid. Of course, well, economics is a big factor, right? So we have our energy prices, so we thought maybe a good idea based on the power consumption, we make a little dashboard given, okay, it's just accepting a fixed power value, but of course, if you want to develop that a bit further, you can of course also hook that up if your electricity provider has some sort of way to give you the power prices with an API or similar, then you can of course make that a bit more tangible to your use case. But it lets you basically estimate what's the power consumption on per device basis. Now, speaking about per device basis, can we take it further? And usually the answer is, on some platforms, yes. We can go down with the telemetry values that we get also to a per line card level. Not on all platforms, but this is, I think we did this on an NCS 5500 platform. If I remember correctly, it's also working on ASR 9K, on 8K, I'm not 100% sure, but I'm pretty sure it should also work. So you can actually take it down to a line card level. And as Bertrand has also shown this morning, we can even, in some cases, have aggregate power sensors that feed into, or that feed all the optics on either a line card, or if it's a fixed box, then to all these opticals. And this way we can also make these kind of measurements for ourselves. If I turn on, turn off a certain optic, what's the actual effect? And then I can evaluate, well, does it make sense to think about shutting down this link to have some power reduction at certain times, right? And this is what my colleague Guillaume will talk about in the next session in more detail. But so the idea is here to give the capability on how to go into these kind of details of measurements, that you can do these well, kind of experiments or evaluations for yourself to have a good idea where it makes sense to save power without having too much overhead or too much adverse effects, right? Right. Last but not least, we talked about cooling and the possible power draw of the cooling. And here we are using some, in this view, first and foremost, you of course see the power again, right, the power consumption on the device level, but also we added some Meraki environment sensors to our lab so that we can have a more granular view on what are the different temperature spots in our environment and where we can possibly see that if we can turn down the cooling a bit, so have a slightly hotter environment without violating any specifications or causing any degradation, right? But still could be able to save some power because we are not running the room at maybe 21 degree or 23 degrees as you see here, but maybe slightly hotter, which is still a valid case, right? Yeah, so these were a bit some of the things that you can do, just measuring, aggregating the data in certain ways, right? And then finding out what could be interesting to you. Now, what are actually some cases where you can find some things directly that could be optimized? And again, I'm coming back to the power supplies, right? So usually those power supplies, and this is an example, right? But they usually look pretty similar, these efficiency curves. You see here, a power supply has a certain rated power, as you may know, and it behaves in a very optimal manner, usually between 20 and 100% of that rated power. Usually, of course, you're running them in redundant mode, right? So you're running them at maybe the 50% point, and it's where there's also, for a lot of power supplies, peak efficiency. But the point is, basically, if you have power supplies that are too big for your configuration of your devices, you may actually get into this bad area, right, below 20 or even below 10%, and this will cause a lot of power being wasted into heat unnecessarily just because the power supply doesn't really fit the rest of the hardware. So we built this one dashboard which gives us kind of like the devices where this is the case, and since this is a lab where we rarely have very big traffic utilization. You see some of them being listed here. And that also ties into another story, right? We can also have a look at devices that are underutilized from a different point of view, from a traffic or bandwidth point of view. And here, the idea is, are there possibly devices that are actually maybe even not used anymore, or that we can see that we can convert to something else because they're rather unutilized from just a traffic utilization point of view? And then I think we've had that mentioned before, right? We can actually make some kind of measurements, even though they're not really comparable across all kinds of different families of devices, but we can try to have a kind of an idea how many watts do I consume to serve, let's say, 100 gigabits of traffic, right? And with that, I can evaluate what parts of my network, what devices are very, in terms of bad, in terms of these kind of power per traffic ratios, right? And I can see what can I do about it, right? Does it make sense to upgrade maybe to a newer generation, because that would actually save me so much power that, given possibly rising energy prices, we see this is a good investment, right? Or in another sense, try to find out what's working very well in terms of sustainability and power consumption and efficiency, and what's not, right? So Bertrand showed it on another slide earlier, right? So we have this ASR 9K advanced power management feature, and here we built a little NSO module for it. That is doing two things, right? So fortunately, we have all the telemetry information available on ASR 9K to automate this a bit. So there is one YANG model which gives you the mapping of all the interfaces towards these slices that we can shut down individually. And of course, we have YANG models that show us what interfaces are active, right? So by combining these two information, we built a little NSO module that can find all the slices that are unused, and then also add some sanity checks that if we actually shut down a slice with this service, that all the interfaces are actually down, right? That we're not accidentally shut down a slice and then pull off, basically, from a power point of view, interfaces that are actually still in use. So that's what we implemented, and also we've seen some power reduction due to this in our labs, right? So that is basically the third kind of optimization use case that we built, and I want to give out a little shout out to my colleague Christina, who's built most of these dashboards that you've seen today, but unfortunately cannot be here with us. Right. So a little conclusion on that, right? So we have we've seen how we can take down power measurements with just either with external sensors, right, or with just what we have in terms of sensors already in our devices. Just by utilizing that, get a pretty good idea how and where the power is consumed in our networks. We can even, on some platforms, take it down even to a more granular level, right, and then maybe see where we can save power, where it is worth actually to save power, which is also an important point, right? How could this be taken further, right? And this is currently one of our experiments. It's not that developed yet, but we have some early working prototypes. But what is the idea here, right? We have these per device power values. So can we actually provide these values not on a per device or per line card or per optical device, pluggable base, but can we actually break it down to the services that we are running on the network, right? So one of our ideas was, okay, we have a layer 3 VPN that's based on segment routing policies, and we can use these segment routing policies, for example, to count the traffic that's going on from all the headends. And this way, we have kind of like a ratio, right? We can say for each device that is carrying traffic for the VPN, we know how much traffic the VPN is consuming, how much traffic the whole device is consuming, and then can we make a ratio, right? We can say maybe 1% of that traffic on that device is caused by the VPN, so we say we attribute 1% of the power and carbon emissions of these devices to the VPN. And then we can make a report in the end, right? So these values are a bit too high because we are running them on lab devices, right, which are not carrying that much traffic, but you get the idea, right? We can have a report in the end. These services are producing indirectly these kind of values, and that could be at some point, I mean, we never know how the legal requirements will be in a couple of years, but these kind of reporting could be important to our customers in the end if they want to know what their services that they booked are causing in terms of energy and carbon impact, right? Yeah, there are also a couple of different projects that we are working on, but I think I'll leave it as that, given the time constraint. And if you have any questions, I don't know if there's anything on Slido, or if you have any particular question, then I'm happy to answer.
So we do have one question. So you had a slide where you talked about pulling information from the devices, and you had a later slide where you talked about carbon footprint. So what was the math between those two things? Do you have a particular algorithm, or are you using a service, or how'd you get there?
So the math is actually relatively easy, right? So because we have the value from the power grid that we can get, right? So we get a value that says, for 1 kilowatt hour of power or of energy that's been consumed from the grid, so and so many grams of CO2 equivalent was emitted, right? Because of the different sources that are in the power grid, right? Coal power plants, like nuclear power plants, and so on, right? And so if we have this value, grams of CO2 per kilowatt hour, we could just multiply it with kilowatt hours that are consumed by the device, and that way get some kind of a carbon impact of the device, assuming we are using grid power, right? Of course, if you have additional power sources, then you need to factor this in as well. And we didn't also take into consideration the AC power, but you can always take it more complex, right?
Sure. I understand. So, I mean, for me, the dashboards and stuff are great. So say someone has the instrumentation already. How difficult is it to take that and turn it into the dashboards and pull this information together?
So for most of these devices, right? I had this slide with the young models. So usually it's one telemetry sensor that you put on each device, which gives you input power, output power for the power supply, and maybe this capacity of the power supply or the required power, right? And with this, you can already do a lot of what you see in here, right? Of course, if you want to go into more detail, then you need to get some more sensors. But usually, it's one telemetry sensor per device that you need to query, which is not that much, right? And then you already get the time series of 600 watts now, 500 watts and a minute later, something like that. And then you can already make a chart, right? And or make an approximation of the power, the energy consumption in total over a given time, right? And then you have the CO2 value. You can multiply that again. You have the other column, right? And that's how you can take it just with these simple values, right?
Okay.
And yeah, that's what we're trying to, and that's why I was saying, right, we have this little open source initiative here that we give you this stack hopefully soon, just with the config files for the dashboards and so on. Then you already have these dashboards, and then you can adapt them to your needs. We give you the config that you put on the router for the telemetry, and then you're good to go, right? You launch that on a virtual machine, and then you can have these some of these same kind of dashboards, right?
Okay, cool. And who do you within the organization? Who do you find is interested in this information? Is it operations teams? Does finance and accounting care about this?
Yeah, I mean, there's different stakeholders that are involved, right? So we actually, this little prototype, we've deployed it in some customer labs already because they wanted to have a look and they wanted to know how to get this information. And I mean, in some customers, we've even seen that some people have targets in terms of energy reduction, right? That they have to meet, and of course, for that, they need to know how to measure that, right? So that's an aspect.
Thank you, Stephen. This was really cool. I think it, really throws into our theme about collecting information and having visibility. So we're now going to keep the ball rolling with Guillaume, who's going to talk about, now that we've collected this information, what can you do with it? So Guillaume, over to you.